Today we're going to talk about the standard form of linear equations. So remember that a linear equation is an equation that relates x and y and not x squared or x to the third or x to the fourth. So we've just got x and y. So far we've looked at slope-intercept form. So this is a review. Slope-intercept form was y equals mx plus b, where m is the slope and b is the y-intercept. And just remember, as an example of that, if I had an equation that said y equals 1/2 x minus 7, we graphed this by using the y-intercept of negative 7. 1, 2, 3, 4, 5, 6, 7. And the slope of 1/2. Rise over run. So we would go up 1 over 2. Right? Up 1 over 2, etc. to make our line. And there's actually a reason that we started with slope-intercept form, because slope and the y-intercept are two really important features of a linear equation. Remember, when we first started looking at linear equations, we just talked about lines in general, and the first things you guys noticed were the different lines have different positions, and that's related to their y-intercept, and then they have different steepnesses, and the steepness is related to the slope. It would seem like we should start with standard form, because it's called standard form, right? But we didn't. We started with slope-intercept form. And now we're going to move into standard form because it's a little bit more complicated than slope-intercept form. And it's not obvious at first with standard form what your slope is or where your intercepts are. But what I'm going to show you is a way to graph a line in standard form by finding both the x and y intercepts. So standard form is ax plus by equals c, where a, b, and c are all constants. A, b, and c are all numbers. Constant numbers. And x and y are our variables. So variables change. They can change. Constants are going to stay the same. So for example, if we look at an example of standard form, it would look something like this. 5x plus 2y equals 10. So 5 is A, 2 is B, and 10 is C. Now this is not the same B that we had in slope-intercept form. It's not our y-intercept. And when you look at an equation like this, it's not as obvious how to graph it as it was with slope-intercept form. I can't just look at the numbers and plot them on my graph. So instead, the way that we're going to graph this is to make a t-chart. So if you have an equation of a line in standard form, you're always going to make a t-chart. What are you going to do?
Make a t-chart.
Yeah. Okay? There is a trick a lot of times to making a t-chart. If your y-intercept and x-intercept are whole numbers, which for all the equations that we're going to do right now, they will be. It's totally possible for them to be fractions. You could get fractions, but we're not going to do that today. We're not going to get any fractions for our x and y intercepts. So here's what you do. To make your t-chart, we know that with standard form, the easiest points to find, typically, are the 2 points where the line crosses the axes. So this would be the y-intercept and the x-intercept. Okay, this is not this equation, but this is like a typical line, right? So instead, in slope-intercept form, instead of finding one intercept and then counting the slope, we're going to find 2 intercepts and connect those 2 intercepts with a line. That's our method when we have standard form, which looks like this. Our method when we had y equals or slope-intercept form was totally different. Okay? It doesn't work for standard form. So what do we know about the x and y intercepts? Well, we know that the point where the line crosses the y-axis is where x is 0. We don't know what y is yet, but we can find it. And we know that the point where the line crosses the x-axis is where y is 0. Well, we don't know x yet. So in our t-chart for standard form, we're going to plug 0 in for x and find y. And then we're going to plug 0 in for y and find x. Now, that's actually really easy. Because if x is 0, what's 5 times 0?
0.
It's just 0. So essentially, when we plug 0 in for x, what we're really doing is just covering up the x term. And we're solving 2y equals 10.
So then it would just be 5.
So y would equal 5. So when x is 0, y is 5. That's the whole reason that we find these intercepts, because it makes these problems really, really easy to solve. It's just one step to solve them. And if y is 0, we go back to our original equation, we can just cover up the 2y. Because 2 times 0 is 0. So when y is 0, then the equation is just 5x equals 10, or x equals, what would x equal here? 2. So when y is 0, x is 2. Now we've got our line, because there's only one line that can connect the point 0, 5. This is the point 0, 5, and 2, 0. Right? The line has to go like this. There's no other possible straight line that connects these 2 points. So just by finding the x and y intercepts, we've found our line. So let's kind of draw this out into what the steps were that we just did. Right? The first step, like step 0, is to recognize whether we even have standard form. Right? So step 0 is to decide what form the equation is in. So for example, if I had y equals 2x minus 3, what form is that equation in? Is that standard form? No, that is slope-intercept form. When I have y equals, it's slope-intercept. And that's when I use the -3 and the up 2 over 1 trick. Right? So y equals means slope-intercept What about this one? 3x minus 2y equals 6. What form is that? That's standard form. When I have x and y on the same side, x and y on the same side means standard form. Okay. So this is, never forget this step. The first thing we have to decide is which technique are we going to use to graph it, and that depends on which form our line is in. So let's take a look at this equation. 3x minus 2y equals 6. Since we decided that this is in standard form, step 1 is make a t-chart with x equaling 0 and y equaling 0. So I make a t-chart. One of the lines is x equaling 0. One of the lines is y equaling 0. This is just reminding me what I'm doing, right? Okay. Step 2, plug in x equals 0 and solve for y. So I'm going to plug x equals 0 into here, and I'm going to solve for y. Now remember, the whole reason that we chose 0 is to make this step really easy. You're not going to get something really complicated when you plug in x equals 0. When you plug in x equals 0, you're just going to forget about the whole 3x. So when I plug in x equals 0, what do I have here?
3. Negative 3.
Okay, let's do it step by step. Negative 2y equals 6, so y equals negative 3, because I divide both sides by negative 3. So yes, those of you who said negative 3 are totally correct, but you probably want to get in the habit of writing out these steps that show you how you got negative 3. Right? I'm just forgetting about the 3x, and I'm finding y. What do you think step 3 is going to be?
2.
Well, not the answer to it, but what is the actual step? Now we do the opposite. We plug in y equals 0 and solve for x. Remember, x and y are a pair. They go together. So if I plug in y equals 0, I'm going to forget about the negative 2y. What do I have?
2. 3.
Well, okay. Let's go step by step. I have 3x, forget about this, equals 6, right? So if 3x equals 6, then what does x equal? 2. So those of you who said 2, you were totally correct. But I want you to remember how you got there. And how did we get from here to here? What did we do to solve for x? Divide by 3. Now, I'm ready to graph. Step 4, plot your points. So remember, this is an ordered pair. This is a set of points. 0, negative 3. So where is 0, negative 3 on my graph?
It's down.
Yeah, 0 means I go over 0. Negative 3 means I go down 3. So that's the point 0, negative 3. Where's the point 2, 0? I go over 2 and then up 0, right? Because 2 is the x. And I'm always going to end up with 1 point along the y-axis and 1 point along the x-axis. Because that's what I found. I found my y-intercept and I found my x-intercept. Step 5, what's the only thing we have left to do? Connect the points with a line. So I'm going to connect these 2 points with a straight line. Ideally, I would use a ruler. And I just have to remember that line goes on and on forever in this direction. There are more points on this line than the ones that I found. Right? I just found 2 points to draw the line. But there's a point over here, right? There's a point over here. There's a point here, here, here. There's actually, technically, a line is made up of infinite points. A line is infinity. It's infinite points all connected together. Going on to infinity. Not only are there infinite points here, there are infinite points there and infinite points there. All right, you guys have this all down? Let's see if you can guide me through an example. So, what if I asked you to graph 5x plus 3y equals negative 30. Okay. What's our first step? Look at your notes. You have them right in front of you. Okay, so step 0, is this in standard form? Yeah, because x and y are on the same side of the equation. Okay? Next step.
Like a t-chart.
Since it's in standard form, we're going to use our t-chart method. What do I put in my t-chart? 0 and another 0, right? X is 0, y is 0. Okay, what's my next step? What do I need to do now? I'm going to kind of take something away. Why? What can I take away now? Yeah, if x is 0, so for this line of my t-chart, x is 0. So I can take away that 5x, which means 3y equals negative 30. Divide both sides by 3, y equals negative 10. I have my first point. When x is 0, y is negative 10. Okay, now what's my next step? Now I'm going to ignore the 3y. So what do I have if I ignore the 3y? 5x equals negative 30. Divide a 5. X equals negative 6. Okay, I have 2 points. How do I graph them? So 0, negative 10 is down 10. 9, 10. That's my first point. Negative 6, 0 is where? To the left, right? Okay, and then my line is going to connect those 2 points. Beautiful. Is the slope of this line positive or negative? Negative, right? Because it's going down. But we don't actually know the slope. With this method, we don't find the slope of this line, right? That's why in slope-intercept form, that's why we started with it, because slope is a really important characteristic of a line. In standard form, we never really know the slope of our line. We could find it. It's totally possible to find it, but we don't usually. All right. Beautiful. I'm going to ask one of you to come up here. I'm going to turn the video off.